Yes, sir.
Okay. So as I told you, today I shall discuss some problems. So first, let me show you the MIPS architecture that if you remember in one of the classes, I discussed about this architecture, but there I did not show the control signals. Now let's assume that these are the control signals. Now you have been given this diagram. Let us assume all the blue lines are control signals and all black lines are data lines, data paths. Okay. So your next 5 minutes, what I will do, you study this circuit carefully. Okay, starting from the program counter to the instruction memory to the registers to multiplexers, different multiplexers, arithmetic logic unit, data memory, things are all given, and all other adder circuits and multiplexers. You also study, there is a control unit. You can see we have not explicitly mentioned that how the control unit is designed, but in this circuit the control signals are shown. Some of the control signals are shown. Okay. Now what I want you study this circuit very carefully, because the question that I am going to show you next, that is, if you want to solve that question, you need to study this circuit carefully. Okay. These things I have already discussed in various ways. I have discussed. Okay, even if the 5-stage pipeline, risk pipeline that I have started designing, they also use similar signals. Here organization is slightly different. This is MIPS, which is also a little bit risk architecture, but MIPS has its own basic data path. You can see that there are some forward lines available. And also obviously the temporary registers are not shown here, like RA, RB, RZ, RY. These things are not shown here. Okay, I mean to say that MIPS might be managing in a different way. Okay, but for the current problem, you assume that this is the architecture. Okay, RA, RB are not there, RY is not there, RZ is not there, RM is not there. Okay. So you need not worry about those. It's not there, that means that they may not be needed here. Okay. Now the question here is, let's assume that these are the two instructions, and RD, RS, RT. You know what is RD, what is RS, and what is RT. And RD, RS, RT. What is the meaning of this one? That is on the right side. Interpretation is given. Register D is equals to register RS ANDed with, bitwise ANDed with register RT. Okay. The second instruction is store word register T offsets register S. So the content of register T will be stored in memory location pointed by register RS plus offset. Now your task is, what are the values of the control signals generated by the control unit in the MIPS pipeline for these instructions? That you'll have to write. And this control signal should be written in order. Okay. So with respect to this circuit, you need to write down the control signals needed for this. Take 10 minutes of time, okay, and work it out using your notebook.
Can you go to next slide once? In the first instruction, first register RS will be loaded in RD and then RD will be ended with register RT, right?
In instruction, which one?
First one, RS will be loaded in RD and then it will be logically ended with RT. RD will be.
No, why? It is RS and RT. Na? There are two source registers, RS and RT. They will be ended and the result will be stored in RT.
Okay. Yeah, I got it.
Can you show circuits?
What I am doing, I am now sending this circuit in the chat box so that you can copy this. I have given this PPT on the chat box. You can directly get it from there itself. Give the names of these signals also. Give a meaningful name so that you can understand. If anyone is done, you can show me your solution. Here your black lines are control lines, huh? Or blue are data.
Yes, sir.
Okay. So let me give the names of the signals. So you are giving the first signal is register. What is that? This is register.
Right, sir. Register right.
Register, then memory read, then ALU multiplexer, then so the first one is and R. Achha, let me share my screen first so that everyone can see. I think all can. Everyone can see your result. Let me first go through it. So if you see the solution Jagdish has given, he has actually shown that for the part A, first one is register. Register means which control signal? Acha. So this is the register control signal. Okay. Register. Okay. So what it will do? It will activate the register file.
Yes, sir, for writing.
Okay. So it will, yeah. So let's assume that it activates the register file. Then a second signal is memory read is 0. Your memory read is not needed. Okay. Then ALU multiplexer is ALU.
The input
to
mux to the.
So the input of the arithmetic logic unit register goes through output. The value which comes from the register file goes to the multiplexer. Another value comes from the instruction memory, and then the third, these are the two values, and there is a control signal. So the signal 0 means it will select the
register.
Okay. Okay. So that means you need to label these signals there. Okay. You need to label these ports. Multiplexer ports should be labeled. Okay. Just make it 0 and 1 so that we can understand 0 means it takes the value from the register, and 1 means it takes the value from the instruction memory. Okay. Right. So then we have memory write. Memory write. Okay, where is your memory write signal? That's here. Okay, memory write signal. Right, so it's not needed. Correct. Then ALU operation. Arithmetic logic unit operation. Okay, ALU operation. So that operation will come. So ALU operation will be of not a single line. It will be.
So like the 0 signal is not taken, the calculated value is taken. I was thinking it's like an enable. So like ALU operation 1 means ALU is enabled, so it will give actual output rather than 0.
That's fine, but ALU enable is that's enabling the ALU unit, but what about the operation? Which operation is going on? This line, even in the diagram, it is shown as a single line. It ideally it should specify that what operation it is doing.
Oh, I thought it is enable type of thing, like because there is a 0 line coming from ALU also, no sir? Yeah, but we need to specify operation also.
Yes, let me see the diagram. The 0 line which is coming from ALU is basically goes to the AND gate. Okay. And what this 0 line is doing? This is for multiplication. The multiplexer just above the first adder on the top side is basically selecting either PC plus 4 or PC plus 4 plus Okay, this is for branch instruction. Offset. PC plus 4 plus offset. So the zero line, if it is non-zero, then only AND gate will be activated. Correct. Okay. So zero line means whenever there is an offset for a particular branch instruction, this zero will be set from the arithmetic logic unit.
So in that mux, then top line should be 1 and bottom line should be 0. I guess.
In the multiplexer, top line should be 1 and bottom line should be 0. Right. Okay. Yeah, it looks fine. Then you have data multiplexer equals to 1, branch equals to 0. It seems to be fine. Only thing is that you need to label it. Let me see other. Sushant has also given one solution. For AND, RD, RSRT, register write equals to 0. This is register reading. Then marks equals to 0. It says that select ALU path from register file. Then ALU operation, it will be AND operation. Marks equals to 1, select ALU path for write back, and then register, store register file. Second part is basically store word, register T. Okay, these signals look fine. Harsh has also given a solution. Let me see. Register write, read from register is one, marks control signal to register file, output goes into ALU. ALU is activated by control signal, output of ALU goes back to control signal, choose ALU output, register write is activated, write back, the destination is. Yeah, so I think that's fine. All these signals are probably correct. Assuming that you are maintaining the sequence. Okay, so let me write down the one possible answers. Let me write down here itself. I am sharing my screen now again. So if I write the signals here, let me see. The first instruction is basically AND RD RS RT. Okay. So first you should read the register read write signal. So guys, you can look, those who have not done it yet, let me tell you that how this can be done. So register write, this signal will be activated first.
during the operand fetch instruction. Okay, operand read stage, second stage. So the values of the registers, which is in this case RS and RT, will be put on the data ports of register file. So one will go here, another one will go here. Okay, so obviously the first one will be register right. Register ID equals to 0. Register ID equals to 0 means it's read. Okay, because the same line will be used for reading and writing. So register ID equals to 0. Let me again see the next one. So the values are here. Next you can see that this multiplexer must, so I need to I need to give the port numbers here. So 0 will go from register, 1 will come from here. Okay, let's assume that the line is 0. So if this signal name is multiplexer ALU, let's assume that this is multiplexer ALU. Okay, so multiplexer ALU signal, I can give this is mux ALU equals to 0. 0 means this one will be taken. So the second one I can see mux ALU equals to 0. Again, I am giving the name, you can accordingly give. So remember, I've given it 0 means I am assuming that 0 will be for this line, 1 will be for this line. So if I write it carefully here itself, so 0 will be for this line, this one, and 1 will be for, this is important, you'll have to write it, otherwise you'll not be able to understand. So this is 1 will be for this line. It's just a convention. I mean to say that you can use your own convention. So 1 is here. Okay, 0 or 1. So that's why I have written it mux ALU, and this is the multiplexer ALU. I have given this name as multiplexer ALU. So this can be multiplexer ALU. The signal is multiplexer ALU signal. Okay. Then let us go to the instruction again. Okay. So in this part, the values are here. There I need to give the arithmetic logic unit operation. Now here ALU operation, it may not be a single bit operation. Okay. So here this line you can say well, I do not know that how many operations will be here. So This is just one convention I'm using it. You can use it. So a 0 0, you can write it that 0 0 means AND. Okay, something like that. But it can only support then 4 operations. If you make it 0 0 0, it will be 8 operations, something like that. So this is just a convention. You can use it. ALU operation equals to 0 0 0. You can here write it that 0 0 0 means AND. 0 0 1 means say OR and etc. Again, this is just a convention. You do not need to you can change it. Okay. So the values are here and this 0 signal will be 0 because otherwise this AND gate will be activating this. So the 0 signal will be 0. So what I am doing here, I am actually assuming that this is my 0 port here and this is my 1 port multiplexer. Okay, so now this 0 signal has to be 0. So what I am doing here, okay, then the value goes here. Okay, and here is memory read, memory write, both should be 0 because you are not using any memory reading operation or memory writing operation, data memory. So memory read and memory write should be 0. Memory read equals to 0. Nothing, and then the value from the arithmetic logic unit goes to here. Actually, they have not given any name to this. They have not given name to the multiplexer control signal, so you have to give another name to this multiplexer. So you'll say this one is multiplexer, let's say multiplexer, let me give a name, multiplexer RF. Register file, let me give this signal name multiplexer RF, and this is multiplexer PC. Multiplexer PC, this signal. Okay, so this is 0, branch is also 0. You can see that there is no branch. Okay, so branch should be also 0. So that ensures that this is 0. So this one will be selected. Okay, now I need to put the value back to the register file. Okay, so this multiplexer RF should be let me give the names. This is my 0 port on this multiplexer, and this will be my 1 port of this multiplexer. Okay, so what I can see, this is multiplexer RF. Multiplexer RF should be 0, so that this one gets selected. Multiplexer RF should be 0. 0. Okay. And then finally the value is written here. So register write equals to 1, so that the value goes to the register. So register so this can be one shell one way writing. Now probably I have not written these signals in right order. That carefully you'll have to look into it, which order makes more sense, whether this will be generated and this can be generated at the same time or not. That you can solve your, you can think about that which order will be more correct. Okay, so this is for the first instruction, and whatever the assumptions I required, I have already put these assumptions here itself. This is 0, this is 1, this is 0, this is 1, this is 0, this is 1. This is the name of the 3 control signals. I have also given some, names to these signals, encoding things. Okay, and also the multiplexer, this one, multiplexer PC equals to 0. This part I'll have to do it. Multiplexer PC equals to 0. So when that signal will come, multiplexer PC will be 0. That can come actually during this one. So ALU stage, when the ALU generates the operation, then only. So it's 0. Or rather you can give it later, because during that time the memory read write, you can give it during that this time, because in the previous stage 0 and branch they are coming. Okay, so the next the multiplexer PC will be something like that. This
Sir, ALU only has 8 kind of operations.
ALU only has
8 kinds of operations. Like
yes, here I have assumed it. Assumed it as 8 kind of operation. That's why I'm using 3 bits. Okay. So this is one way you can write down the control signals. Again, I told you the signal names I have given it, and there are certain assumptions which I have made it. So this is one way. So I hope that you will be able to do it for the next part. Okay. So those who have not done it, now follow the same logic or same convention that I have used here. Can you complete the answer for the part 2? Those who have not done it, okay, just write the signals here itself in this order. I'm just giving a couple of more minutes time to all. So just use this convention, signal conventions. I do not want answer from 1, 2, 3. I mean to say that I would like to know that whether all of you are able to do it or not. Those who have not tried yet. Hertz has given a solution. Probably right.
So can you check the data mux part once?
Data marks.
The one which is present after the ALU.
Data marks could be anything 0 or 1. Step number 6, you are saying?
Yes, sir.
Step number 6.
Data mux is that mux which is present after the ALU.
Which is present after the ALU, that means which is either taking from data memory or
yes, sir. Or ALU.
So you have given this is data marks, which I actually named it as multiplexer RF.
Yes, sir. Multiplexer.
So it should, what you have written it data marks to be anything 0 or 1. You are saying 0 or 1.
मतलब ALU की भी choose कर सकते हो आप memory.
ALU का भी नहीं. Why? This is store word ना.
So it should choose memory one.
Store word means that something will come from the see one thing, this multiplexer, the first multiplexer, ALU multiplexer, that multiplexer basically selects the offset. That multiplexer selects the offset. Okay, and so the offset plus RT now, what is that? It is RS. Offset plus RS. Offset plus RS gets added, and that goes to the address. Okay, and your data which is coming from the register file, it goes to the memory through data port. So and the memory it's basically store operation. So the memory write operation goes, memory write is 1, memory read should be 0.
Yes.
And the data and the marks here itself is basically it can be 0 or 1, right? It's not used. Yeah, right.
So it should be off directly.
It should be off.
Enable
right.
one.
It should be off, right?
Yes.
So it doesn't matter if it's off or not because we've given register write as 0. So even if we send some data, it will not affect the register.
Right. So that means that's correct. So because register write is 0, so nothing will be written back. Okay. So even if it is 1 in the multiplexer, it doesn't matter.
Yes.
What about others?
Sir,
Yes.
sir, will it be fine? Like I was thinking that RS will be loaded in the upper part of ALU and RT will be loaded in lower part of ALU through 1 mux. And offset will be coming from directly immediate value.
कहाँ से आएगा offset immediate value? देखो तुम अगर if you look into the instruction from the instruction memory, okay, the value goes to the multiplexer only.
या सर तो वो वही इमीडिएट हो जाएगा ना जो मक्स में जा रहा है नीचे वाली पार्ट
मार्क्स में जा रहा है जो इमीडिएट हो जाएगा और ऊपर से आएगा तुम्हारा
ऊपर से आरएस
नो नो सी द पॉइंट इज आरएस ऊपर से आ रहा है 1 मिनट आरएस मतलब जो ऐड होगा ना वही तो हम बोल रहे हैं दैट्स व्हाट वी आर सेइंग
एंड सर जो लोड होगा वो नीचे वाले से आ जाएगा मतलब आरटी जो है
जो लोड हाँ वही तो दैट इज व्हाट इट इज कमिंग ना
ओके सर
दैट इज व्हाट इज कमिंग आरटी विल इज कमिंग थ्रू द नीचे वाला जो लाइन है डाटा पोर्ट जहां पे है RS will come through the top one, RT will come through the below one from the register file, and then the multiplexer will select the offset value. That's what we are, talking about. I think the solution that what Hertz has given, I think that is the solution. I didn't look in the upper part. Yeah, marks before ALU equals to 1. Choose immediate value or offset. Okay. That's right. Yes, explicitly there is no need to mention it because it is explicit that the value of RS comes through the
So because of your previous naming convention, the value of RT should come from 0 and RS should come from the first non-interrupted one, because we only
Right.
make selections between RT, right?
Right,
So
right,
it should come
right.
from the lower one.
right. That's it.
ओके सर
Guys, all other guys, क्या हो रहा है?
Sir,
बोलो.
sir, is one of the one out of the 3 registers given here the instruction register? Because when we are choosing like one of the registers in the 3 registers given is instruction register.
One of the 3 registers is given as instruction register.
Because when we are writing that mux ALU 1, so immediate value is being added, so it is but the channel is given from one register itself, so like
No. It's not channel is from the on register, the same line actually. If you look into it, so the value which is coming from the instruction memory, okay. So register in IR is not explicitly mentioned here. Okay, ideally in the instruction pipeline you should mention IR. Okay, because instruction register contains the whole instruction 32-bit instruction. Okay, and here the offset only comes. Okay, so the separation it has not been shown here. That's why I told you this circuit is not complete circuit. Okay, it is showing that whatever the coming from the instruction memory, they can go to the register file as well as they can also go to the multiplexer below multiplexer. Okay, so the separation it has not shown it, but the separation has to be there. There will be instruction register some portion, because what you will do with the complete instruction giving it to the registers, you do not need to give it to the registers. So that separation or field separation of the instruction is not shown. Okay. For example, if you look into it, there is a blue line coming from instruction memory to the control unit. So that is basically opcode part. Definitely it's suggesting that the opcode part is going. Is it clear?
yes sir.
अच्छा एक काम करता हूँ, मैं तुम लोगों को और एक क्वेश्चन दे देता हूँ, and then in the meantime I'll take the attendance also. So this one is an extension of the current problem. इसको थोड़ा देखो. कहाँ पे है हम? Yes. So इसको देखो. Is it visible? The second
Yes.
question? हाँ, इसको
Yes.
देखो. Solve करो. In the meantime, let me take that. Chandra Prasad. 16/22, 16/36, roll number. $38. Supriya.
Present, sir, present.
Sudhanshu. Venkatasai, 18 batch.
Present, sir.
Are you following, Venkat?
Yes, sir.
Venkatasai, are you following the questions?
Yes, sir.
You are able to understand?
Yes, sir. I'm understanding.
ठीक है, इसको समझो ठीक से. Tarun,
Yes, sir.
are you understanding?
Not fully, sir. Already.
Why? Why not fully? Which part you don't understand? Let's
Sir,
know.
I will again see it once after the
ठीक है.
class.
हाँ ठीक है. देखो 1002 अविराम. निहांत. भरत. अखिल. Roll number 5, 1005. पवन कुमार.
Present, sir.
अर्पित.
Sir, 5 Akhil. Hello, sir.
हाँ क्या हुआ, कहाँ गए थे? Where you went?
Sir, I'm here only. Sir. I'm not able to on
Arpit.
mic properly.
अर्पित. अर्पित. अनुदीप.
Present, sir.
सुजीत.
Present, sir.
नीतीश.
Present, sir. Present, sir. Present, sir.
Okay. रोहित रेड्डी. 11.
Present, sir.
Roll number 12 नवनीत.
Present, sir.
Roll number 13 सुकृत.
Yes, sir. Present.
Sir, 2 Abhiram was present.
हाँ
002 Abhiram, sir. I just lost net connection for a moment.
lost my connection. Every time attendance lost my connection. Okay.
Sir, every time I am there, sir. I just lost now.
Okay, ठीक है. ठीक है, I've done it. कुशाग्र.
Present, sir.
विजय केतन. विजय. $16 अविनाश. $17 किरण रेड्डी. ज्योति किरण रेड्डी.
Present, sir.
18 दिव्यांश.
Present, sir.
19 राहुल.
Yes, sir.
20 अतुल. अतुल. 21 अभिनव.
Present, sir.
22 अजीत.
Present, sir.
23
Present,
यशविनी.
sir. Present, sir.
हाँ साइड. 24 निहारिका.
Present.
25 श्रावणी.
Present, sir.
26 जानवी.
Present, sir.
27 भरत कुमार.
Present, sir.
28 Parth.
Present, sir.
29 Vidya.
Yes, sir.
30 Nandini.
Present, sir.
31 Ades. Ades. 32. 32.
Present, sir.
33.
Present, sir.
Yeah. 33.
Present, sir.
34. 34 Dheeraj. 34. 35 Aviram. Aviram 35. Vikas 36.
Present, sir.
Vamsi 37. Vamsi 38. Saket
Yes, sir.
39. Nikhil. Nikhil 40. Anirudh
Present, sir. 40 present.
41. Yeah.
Sir, 41 present.
Yeah. 35 Aviram, are you there? Santosh 42.
37 present, sir.
37 is present. ठीक है.
Sir, 42 present.
Yes. 43 Sindhu.
Present, sir. Present, sir.
44 44 Akshaya. 44. 45. 45. 46. Abhijit. 47. Pavan Kumar.
Present, sir. Present, sir.
48. Praveen Kumar. 48. 49. Satvik. 50. Satvik. 49 Satvik. 50.
Hello, sir. Present.
Yeah. Okay. 51 Manoj. 52.
Present,
Vinit.
sir. Present, sir.
53 Vamsi.
Present, sir.
54 Jyoti Priya. 54. 55 Dinesh.
Present, sir.
56 Dhruv.
Present, sir.
57 Kishore.
Yes, sir. Present, sir.
58 Vinayak.
Present, sir. Present,
59, yeah, 59 Sujatha.
Present, sir. Present, sir.
60 Rapeti Mohan.
Present, sir.
61 Hers.
Present, sir.
62 Sangram.
Present, sir.
63 Jagdish.
Present, sir.
64 Yogesh. Yogesh. 65. 65 Prashant. Prashant. 2001 Sai Krishna.
Present, sir. Present, sir.
2002 Dhiren.
Present, sir.
2003 Sarthak.
Present, sir.
2004 Harshvardhan.
Present, sir.
2005 Deepti. 2005 2006 Kaushik.
Present, sir.
2007 Durga Prasad.
Present, sir.
2008 Agamya.
Present, sir.
2009 Likita.
Present,
Likita.
Present.
Okay. 2010.
Present, sir.
Anuj.
Present, sir.
2011.
Present, sir.
2022.
Present, sir.
Okay.
Hello, sir.
Hmm.
Sir, CS 65, Srirang Deshmukh, present, sir. My mic wasn't working at the time.
Okay.
Excuse me, sir.
Yes.
Sir, CS 1020 present, sir.
10.
20.
What you have been doing there? क्या कर रहे थे उस टाइम पे?
CS 35.
ठीक है अभिराम, रोज
Yes, sir.
हमारा प्रॉब्लम हो रहा है अटेंडेंस के टाइम में.
Hello, sir.
हाँ
My mic work now.
Sir, CS 0.064.
010 Yogesh. Roll number. What is your roll number?
64. BTech 64.
हाँ 64 योगेश ना? यस हाँ हाँ ठीक है. Anyone done with the second part of the problem?
So we are assuming that every control signal is off at first.
हाँ
So program counter side of things we can ignore, right? Because PC and all those times are not given. Only the
Program
after
counter
the
means?
instruction memory. So like all the component time latency is given after the instruction memory.
Hmm.
Like
Yeah.
the
So
one
these
step
are,
behind all the group.
yeah, these are complete. These are inclusive of everything. Okay, all the values are given. Okay. Like for the first instruction, instruction memory takes 200 PS picosecond, whereas for the second instruction it takes 750 picoseconds. Okay, so that includes all other things to be done for separation of the data fields and other things and everything.
We can assume, right, that we are doing it in the minimized way. Like time will be reduced.
So basically, if you look into it, the latencies of block along the critical path, which is basically the longest latency. Okay. Critical path means it's the longest latency. So
I mean, like from control signal from control unit, I can send control signals simultaneously to all the units. Like in 40 seconds, all of that, 40 picoseconds, all of that will happen. All the controls.
Right.
Sir, I had a doubt in the first instruction where you said that the register write is going to be 0 and afterwards the register write was supposed to be 1 because we were writing in the AND instruction.
Right.
So that is supposed to happen over 2 clock cycles, right? So we can't do that in.
No, basically, I'll tell you here you can if you go to this diagram, okay. So now look into the stages here. Instruction memory takes 750 picoseconds. You're talking about the first one. Instruction memory takes 200 picoseconds. Okay, so that 200 picosecond means the reading the value from the instruction memory, giving it to the register file. So that it takes 200 picoseconds. Okay, so second case, let's say you are talking about addition operation. Addition operation takes 70 picoseconds. Okay, for the first instruction. So this this adder takes 70 picoseconds. Okay, so what is your question then?
So my question is, in the previous question where you had written all the control signals, you had given 7 signals. In that you had written register write twice because first we did not need to write, and in the second phase we had to write back in the register. So that needs to be done over 2 clock cycles, right?
These are control signals. These are control signals. These control signals are generated by the control unit only. Okay, these are control signals, and the time.
So these cannot be simultaneous, right? These cannot be simultaneous, right? Because
these cannot be simultaneous. Why not? The control signal will be generated. The overall control signal generation takes 40 picoseconds. Now that's what.
So, but because you had written register write twice, so once when you give it a 0, you'd have to wait for another time to send 1, right? You cannot simultaneously send 0 and 1.
Right. So obviously, so if you basically find out the sequence, okay, so some of this will be done parallelly. Na? See, it's not. Okay. If you look into here, all these things, IM, add, marks, ALU, register, DM, and control, some of them will be going on parallelly. So the control signal will be active several times. So let's take the first instruction, AND instruction. The AND instruction, what it does? AND instruction is initially read from the instruction memory. So that instruction memory, it takes 200 picoseconds. So you add 200 picoseconds. So what is the critical path of an MIPS instruction? Critical path of how I am defining the critical path. So earlier, like this is figure, in this figure itself we are showing the entire path. Okay, so the critical path for this instruction, the first instruction, you can look into it that the instruction comes here. So the reading from the instruction memory takes 200 picosecond. Okay, and then where it goes? Then it goes to the registers. Okay, now while the registers are, if you want the values to be coming out of the registers, how much time it takes? Let's see that registers takes 90 picoseconds time to read the value. Okay, now you are saying that whether the control signals that will be generated to read the values for the registers, obviously these control signals will be 40 picoseconds needed to generate the control signals. Okay, so 200 plus 40 plus 90. Why is this 40 is required? Because you require to generate this signal, register write signal. Okay, accordingly you'll have to add it. Okay. Someone has given an answer. What is the answer? And you have given 200 plus 40 plus 90, right? I think this way you'll have to generate the longest path. You'll have to generate 290 plus, but here basically you have given 40 for the generation of the signal, then it goes to 90, correct, from the register.
Sir?
Okay. And then I think whatever the convention you have followed, hers, it is correct.
Yes, sir. I was asking that for the mux which is present after the register.
The marks after the register.
Yes, sir. So
let me see that this answer Jagdish, who has given, this is Jagdish. Jagdish has given an answer which seems to be more realistic in nature. If you look into it, basically if you construct this graph, okay, I think that gives the better understanding. Some of these paths, so because you are looking for longest path, you will find that which one is going to be the longest path.
Yes, sir.
So people, if you look into the answer that Jagdish has given, I have not checked it fully, okay, but it seems to be the approach is correct. You must start with the starting point, which is reading from the instruction memory, and then from the instruction memory it goes to the register. Instruction memory takes 200, register takes 90, okay, and you can directly go to the register, or you will have to take the control unit. Control unit takes 40, so that is the longest path. Okay, so 200 plus 40 plus 90 after you reach the register. Okay, from there you basically go to the multiplexer.
So, but at first we don't have to give any control signal to register.
Where?
At first we don't have to give any signal to register because it is already off. A register, we are giving control signal to register only for writing operations, right?
No. Register write is that the register write. That's a single line, na. So you'll have to read the value, na. If the write value is 0, that means it's reading.
So it is default 0.
No, it's default 0 means you'll have to give the signal, na. It's not default 0. The point is the signal. It is a single bit, 1 bit signal. 0 means it's doing reading. 1 means it's doing writing.
Okay, sir.
But in this solution, there is one doubt, like first for register, it will not be only 40 millisecond, because after that we also need to give register write signal. So we have to change the signal.
Register write will be at the end, na?
Yeah, so that should also be included, right?
Right, huh? So that's why I told you I have not checked the complete part. I have not checked the complete part. What the end when
40 PS is missing at the end.
for multiplexer, it needs to go through another path 40 plus 200 to register from the last multiplexer, probably. That's what you are talking, na?
Yes, sir. Sir, there can be, I think, sir, answers may vary because some control signals we might take in parallel, or some control signals we might think in series, maybe.
I have not find out, I have not prepared a model answer for this one, but I'm leaving it to you. We will solve this, okay? Which is, logically, you'll have to think about it. That I don't think that there will be multiple answers. There will be one answer itself, okay? But you'll have to figure it out that that answer actually covers all paths. Because my assumptions are already, I have written the assumptions here in this diagram itself. Okay, only thing is that whether I have written the sequence here correctly or not, that you'll have to look into it, whether this sequence makes sense or not. If this sequence is correct, that 1 to 7, that sequence I have written, then accordingly I think you can generate it.
Sir, can you see once mine sequence? It is means I have logically written sequence, how it will go and how might it will go.
Just opening. So memory, instruction memory, then it goes to control. Okay. Then it goes to register. Then it goes to control. Then it goes to arithmetic logic unit. Then it goes to control. Then it goes to register. Instruction memory 200, control 40, then registers. Okay. Then again control, then arithmetic logic unit, then control, then register. Looks to be sequentially correct. Okay.
So you can take the control and ALU in parallel, right? You'll not need to take it in sequence. So you save the 40 there.
Control in?
Control and ALU in parallel. While the ALU is running, you can send the right signal from the control.
While the ALU is working, you send the right signal from the control. Right signal to register write you are talking about.
Yeah, register write. Yeah. Register write equal to 1, you can send in that time and you'll save that 40 minutes.
No, but if the data is not available, how can you send it? See, the register write can only be given when the multiplexer RF signal is available. Na? That multiplexer, see, the first signal to be generated before register write is the multiplexer RF signal. Sushant, did you consider this signal, multiplexer RF signal, which is generated by control unit?
That is missing, I guess.
In the last part, I have said that control signal, register write, and mux data is RF basically. Mux data which I have mentioned, it is mux RF basically.
Okay. Yeah, so that's the last control signal. I got it. So unless the data is available, you cannot give the register write signal. So register write signal can only be done when the ALU completes its operation. So after only the ALU takes how much time? ALU takes basically 90 picosecond. After the 90 units of time is over, then only you can generate the control signal for, let me see Sushant's marks data, register write, but can you generate this parallelly? Marks data and register.
Sir, using your logic, then we'll have to add the control signal a lot more number of times than Sushant has done it. Because you'll have to take into consideration that then you'll have to give a control signal into ALU also after the register file is done reading. So 200 plus 40 plus 90 plus 40 plus ALU, and then again another 40 for the marks, and then again another 40 for the register write one.
Right, na, that's correct. That's why it's a critical path. You'll have to find out the path which does not create any confusion. Data should not be overwritten. So all the answers, which I'm not saying that which answer is correct or not. So basically, you try to understand in a circuit. These are digital circuits, okay? So whenever, even if a single gate, it takes time to pass the signal. Okay, so that's why these values are given. So carefully look into that. Whether the answer that you have written, they are correct or not. I'm not saying any commenting anything whether it is correct or not, because I have not critically analyzed it. But in your spare time, just look into it.
So basically every step will have to have a parallel control, because you cannot start generating control signal before knowing that previous operation was finished.
Right. So that's why these control signals, that's why I have given in a sequence. That is the reason I have given the control signals in sequence. In this sequence, if you look into the PPT where I have shown the control signals in sequence. So the first of all, you will have to identify that whether this sequence is correct or not. Okay. So you again look into this sequence, whether this sequence is correct or not. If this sequence is correct, then I think you will be able to make some of these signals can be generated parallelly also. That's why I told you I don't know that whether these this is the correct sequence or not. I just listed down. Some of them can be parallelized also. So do this by yourself. And then another one, I am giving you a question. So this one, I am again putting it back to the chat section. Again.
So could you please at least provide the answers so that in a free time when we are practicing it, we can verify our answers.
Okay, I'll do this. This answer I will give. This critical path answer I will give. I'll upload it. Actually, I have not solved it yet. I've uploaded these questions. I will work it out. The solutions I will work it out, and I will upload it. There is another question given for designing circuit in part 3, which is this question I have a similar question I have already discussed in the class itself, designing. So you can look into that problem also. Okay, thank you then, and all the best for your examination.
So,
your mid-semester questions are rather easier than whatever I have discussed today, that I can tell you.
सर आज वाइवा हमारा होगा क्या?
हाँ
आज हमारा वाइवा होगा क्या?
हाँ हाँ आज I'll take.
रोल नंबर 61.
हाँ हाँ आज तो definitely तुम्हारा होगा. Today I'll try to complete all. I'll make it. COA all I probably I'll do it. I'll complete it today.
Okay, sir.
Okay then, thank you.